Welcome, ladies and gentlemen, to section 4.7. All of my geometry students that are looking forward to the end of chapter 4, this is it. This is the last section, and this is overlapping triangles. Really kind of an add-on. You don't really need this, like there's no notes for this. It's just over examples, but is a little bit more challenging, so that's why I wanted to make this video for those that are struggling seeing these overlapping triangles. Let's go ahead and jump into the first example. What common angle do ACD and ECB share? Okay, so ACD is, let's kind of label these triangles. So ACD is this triangle. Always good to kind of draw out your triangles first. And then we have ECB is this triangle. Okay, so it says what common angle do they share? So if I were to draw this separately, okay, what I'm going to do here, if you have notability, you can do this also, but if you don't, it's okay. You'll have to redraw it separately. But this is the same triangle I just drew. This is the same triangle I just drew. Okay, so I have the two triangles separated. Now, what do they have in common? Well, clearly they don't have this angle, and let me change the color, and I'll change and this angle in common. So this would be that angle, and then this one would be that angle. They don't have that in common. They don't share that angle. Okay, what do I mean by share? That means they overlap. They both have the same angle overlapping. Now, what about the next angle? What about this angle right here? Okay, this angle right here is here, and as you can see, that would be in the middle of this triangle, so clearly that is not a shared angle. Okay, so let's check the third and final angle for the green triangle, and that would be this guy right here. Now, is he on the purple triangle? He is. He is also on the purple triangle, like this, and like this. Okay, so that is the shared angle. Angle C is the shared angle there, but you really need to draw these out for those that can't see it, and really kind of look at it carefully. You can see that they both share kind of part of a side. Okay, so this side right here, but it doesn't go all the way up. There's no other shared information between these two triangles. This side is on the purple, but it's not on the green. Okay, so you can see that there's only certain aspects of each triangle that do in fact overlap and are shared. In this case, it's only angle C. Let's go to example 2. You're going to see that we have a few more with this one. What is the common side in ABD? Okay, let's draw it out. ABD. Here's my green one. And then let's go the purple again. And then DCA. So we go DCA. Okay. Now, if you want, we can separate the two triangles so we can see them a little bit more clearly. We have this purple one here. Isn't Notability pretty cool? I'm not even sponsored by them. But if you work for Notability, just give me a holler. Okay, so we have ABD. So ABD is the green one, DCA is on the right. What is the common side? Okay, well, it might be hard after you separate them to see, but there is a common side here. Now, you might say, oh, they have the same length here. Well, we don't know that, okay? You're making an assumption based on information that we don't have available to us, okay? So we have to go based on the diagram alone. Okay, now it's actually easier to see it as we overlap it, what they have in common. And as you can see, we have a reflexive property here. This ability to separate the two and then bring them back together is the easiest way to see that we have a common side here. And as you can see also, we do not have a common angle. Okay, it doesn't line up like it does over here. These ones, let me line this guy up. Okay, we can line up the angle and it overlaps perfectly with the angle. This one is not the case. These two angles, or these three angles, do not line up with each other, but the side does. So we can see that it has a common AD side for both of those. What is a common side in ABD? Okay, that's my green guy again. And this time it's BAC. Okay, BAC. We're changing it up. Let's get the purple highlighter, BAC, going this way. Okay, like this. All right, I'm going to grab it, and I'm going to separate it again just a little bit, just so we can get an idea. Ooh, got a little bit uglier this time. Okay, now we're looking for the common side. So again, here's the separate, kind of hard to tell. Separated, we'd have to make some assumptions, but as we line it up and see it separate from the huge diagram, you can clearly see where the two sides line up and overlap to form a new color, and that's right, let me change the color here, that's right here. okay? And that would be BA is the side there. So BA, overlapping side. Half the battle is just being able to separate that because that gives you vital information for your proofs. Speaking of proofs, this is a challenging proof here. I wrote it as a challenge for my honors geometry students. The challenge is prove QPT is congruent to QRT given this information. Okay, so first let's highlight the two triangles we want to prove. So we want to prove QPT, this guy, and this guy. And we know very little information about both these triangles. Very little. So this is going to be a little bit difficult, but we'll get there. So we are given that PS is congruent to RS. Okay, that's given here. PS is congruent to RS. And angle PSQ is congruent to RSQ. And that's also given there. Okay. So we know a lot about these two triangles here. Let me highlight them in blue and pink. We know a lot about these two triangles. So what we're going to do is we're going to start with what we know. We're going to work with these two, the pink and the blue triangle first, and then see if it leads us to anything with the purple and the green. Okay, so we already are given a side and an angle. Okay, that's the first thing we're given. We're given a side and an angle for both the pink and the blue. Okay, now there's one part that's already given for us, and that's that SQ is congruent to SQ. Well, that one's, yeah, so we have SQ is congruent to SQ. All right, so we have another side here. So we're going to write side. And why is that? It's because it's reflexive. And I just realized I highlighted the wrong triangles, but that's okay. Let me show you. Okay, so let's highlight the reflexive side, reflexive SQ. And you can see that this is not, we don't want to know about these two triangles. We want to know about these two triangles using that reflexive side. So we want to know this big triangle here. And that makes a little bit more sense. Okay, I highlighted those smaller ones, but that doesn't really make sense to highlight those small ones because they don't contain the purple and green triangle that I wanted. I need a big triangle that encompasses the purple and the green, and this time they do. These little triangles that were in here, that doesn't do that. So I want something that contains those triangles because then I have more information about them. So I have this reflexive side that I posted there, and now I know I have a side, an additional side, and I'm just going to actually put it down low a little bit. Okay, I'm going to put it over here, even though it continues up for both of these. And now that I know that PSQ, that's my pink triangle, is going to be congruent to my blue triangle. Okay, that's this guy. And what is the name of that triangle? Well, we went PSQ, we went PSQ up, so we're going to go RSQ up. So triangle RSQ. Why is that? Well, we have it here right in the diagram, SAS, side, angle, side. So now we have those two triangles are congruent. So that's pretty cool. So we know that the big blue one, and I'm going to cut these real quick. I'm going to erase these so you can see it. Okay. So we have these two triangles are congruent. Now, keep in mind, we wanted to know about the green triangle and the purple triangle, but at least we have part of that information already. So that's good. Now, angle PQT. PQT. Notice how T is here, in case you didn't see it. PQT. That is this angle here. So I'm going to make it with 2. We're saying those are congruent. Now, what would be the reason that those are congruent? Well, first off, it's an angle. So I'm going to list angle here. Usually I just put an A, but I want you to see that it's an angle. But what would be the reason here? Well, since we proved that the blue and the pink triangle are congruent, we can say that all the parts are congruent because of CPOC-TAC. Some geometry teachers will call it CPCTC, but I call it CPOC-TAC. I think it's a little easier to say. That just means since we already proved side angle side for the pink and the blue, everything about them is also going to be congruent. That means these sides will be congruent. These sides will be congruent. And then we already showed that those sides were congruent. We already said reflexive side there. And also 1, 2, 3, but we're not going to use this angle, but 1, 2, 3 for those two triangles. We know everything about them. All their sides and all their angles are also congruent. Okay, so that's one thing. Now, what else can we say? We can say PQ is congruent. I just kind of demonstrated this. Congruent to RQ. And why is that? Again, see POC tag. Because we know everything about these triangles is congruent, we know, and that's the side, we know that even their sides are going to be congruent. So the side of PQ for the pink triangle is going to be congruent to the QR side of the blue triangle. Okay? Now, we need one more piece of information. So if let me erase the pink and the green in a second. Or blue, sorry. Look what we have here. We have a side on the purple, a side on the green. An angle on the purple, an angle on the green. We just need one more piece of information. Well, guess what that is? 1, 2, 3. It's this reflexive side again right here. So we're going to use that reflexive side, and that is QT congruent to QT. And that's my third side, or sorry, third piece of information. This time is a side, and that is the reflexive property. Now I can prove that the purple is congruent to the green, my purple being QPT, my green being QRT, because of why? Side, angle, side. So there you have it. So this gives you some CPOC TAC exposure. This gives you some overlapping triangles exposure. This is a pretty tough problem, but hopefully you're able to follow along. Remember, you're always building an argument from one step to the other. Sometimes once you get to like side, angle, side, you know you're going to have to use CPOC TAC only after you prove a triangle congruent. Other thing is, you can always look to the diagram for additional information. The givens should lead you somewhere, the diagram should lead you somewhere, and then you can look to the prove to kind of direct you on where to go after that. Hope you enjoyed this video on 4.7. Thank you so much for watching, and I'll see you next time.